The sum of two consecutive integers is 41. Determine the integers. So our first step, read it carefully and make some notes. Well, it's fairly short, but there are some challenges. Our first challenge is that term consecutive integers. Consecutive integers would be one after the other. So 3 and 4 would be consecutive integers. 101 and 102 would also be consecutive integers, in that 102 is 1 bigger than 101. So consecutive integers mean that the bigger number is always 1 bigger than the previous one. And we also see from our question that our two numbers have to add to 41. Remember, sum means addition. So, on to step 2. We can go back and read it again, but do we have a good idea for setting the variable? Let's see. If we say that the variable is x, and that x equals the smaller number, then our larger number should be 1 bigger. So, x plus 1 could be our larger number. Documenting it like this will help us set up the problem and will definitely help us sort it out in the end. We're on to step 3. Translate and solve. So we're told that the sum is 41. So the smaller number x plus the bigger number x plus 1 has to equal 41. And it's time to solve. So we can bring the x's together. 2x plus 1 equals 41. And we're on to isolating that variable x. So we'll subtract 1 from both sides, keeping it balanced. 2x equals 40. We're multiplying by 2, so let's divide by 2, and we have x equals 20. So x equals 20 is our answer? Can we just leave it like this? No. We wouldn't have the full answer nor full marks if we just left it like this. So step 4. Let's refer back to the question. It says, determine the integers. So what is that x equals 20 telling us then? We documented that x equals the smaller number. So our smaller number is 20. Great. But to fully answer the question, we also need to provide the larger number. We documented that x plus 1 is the larger number. So our larger number here is 20 plus 1, or 21. So our two numbers are 20 and 21. And yes, we can confirm they are consecutive, and if we add them, we get 41. So perfect, we've confirmed. Example 2. Amber is 3 years older than her sister Alice. Their combined age is 35. What is the age of each girl? Our first step, read it carefully and make some notes. We have Amber and Alice sisters, and Amber's older by 3 years, and their combined age is 35. So on to step 2. We may go back and read it again, but did we get an idea for the variable? Let's see, if we say that our variable is x, and that x is the age of Alice, the younger sister, then the age for Amber is 3 years more than that, or x plus 3. Now, could we have made x equals Amber's age, the older sister, and then Alice would be x minus 3, or 3 years younger? You bet. Either way would work perfect. Choose the approach that makes most sense to you, and just make sure you document it so you're clear in the end. We're going to go ahead with our plan here. We're on to step 3, translate and solve. We're told that the combined age is 35. So Amber's age, that is x plus 3, plus Alice's age, x, comes out to be 35. And we're ready to solve. We can bring the x's together and we have 2x plus 3 equals 35. And we isolate the variable. Let's subtract 3 from both sides, keeping it balanced, and we have 2x equals 32. We're multiplying by 2, so let's divide by 2, and we end up with x equals 16. So is x equals 16 our answer? Can we just leave it like this? We wouldn't get full marks out of that. we have to go back, step 4, to the original equation and check. We're asked, what is the age of each girl? So the x equals 16, well, that tells us Alice's age. So Alice is 16. But we still need to provide Amber's age. And we documented that x plus 3 is Amber's age. So Amber equals 16 plus 3, or 19. Amber is indeed 3 years older than Alice, 16 versus 19. And if we add 16 and 19, we get 35. So confirmed.
Dean has a piece of wood that is 3/4 of a foot in length. He needs to cut pieces that are 1/16 of a foot long. How many pieces can Dean cut? After reading this story problem, we should recognize that we can use division to solve. Basically, we are trying to figure out how many pieces of wood the size of 1/16 of a foot can be divided into a piece of wood that is 3/4 of a foot in length. So one thing we can do is take 3/4 and divide that by 1/16. Be cautious when setting up a division problem because the fraction you write first and the fraction you write second is very important. If you were to put the fractions in the wrong order, you would come up with the wrong answer. Just remember that the amount that you are starting with, that is to be divided up or chopped up, must be written first, and the other fraction goes second. After setting up your problem, rewrite the first fraction and multiply it by the reciprocal of the second fraction. So we are going to multiply 3/4 by 16/1. The next thing we can do is multiply the numerators together. 3 times 16 is 48, and the denominators have a product of 4. Because we have an improper fraction, we are going to divide the numerator by the denominator, and 48 divided by 4 is exactly 12. So if we were to cut a piece of wood that was 3/4 of a foot in length, we could get 12 pieces that were the size of 1/16 of a foot long. Another strategy that we can use to solve this problem is by drawing a diagram. So I'm going to start by drawing a line that represents the length of the piece of wood, and I'm going to start by marking the beginning of that piece of wood as 0. We're going to say that this right here is 1 foot. Halfway, of course, is 1/2 of a foot. This would be 3/4 of a foot, which is actually the length of the original piece of wood. And this mark right here is 1/4 of a foot. Now it says that Dean wants to cut his wood into pieces that are 1/16 of a foot. So now I'm going to divide this entire foot into 1/16 of an inch. So this quarter has to be broken into 4 sections. This quarter into 4 sections. This quarter into 4 sections. And this quarter into 4 sections. Now all I simply have to do is see how many times I can fit 1/16 into 3/4. So I must stop when I hit this mark right here because that's how long the piece of wood is. And from this point to this point is exactly 1/16. So that would be 1 piece of wood, 2 pieces of wood, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we can see that 12 pieces of wood the size of 1/16 of a foot would fit exactly into a piece of wood that is 3/4 of a foot in length.
A bag contains only red, gold, and green counters. Red, gold, and green, red, gold, and green. Alice takes at random a counter from the bag, and then she puts the counter back in the bag. Bob does the same. He takes at random a counter and then returns it to the bag. The probability that both counters are red or that both counters are gold is 5/16. The probability that the first counter is red and the second counter is not red is 1/4. Charlie takes at random a counter from the bag. What is the probability that Charlie takes a gold counter? This problem is adapted from a GCSE exam. Similarly, this problem translates into the following equations. This is a system of two equations in two variables, and I expect you would be able to solve this. You would solve for x, and then you would go and solve for y, which is equal to 1/4, and that's the probability of drawing a gold counter. But how do we get to these equations? Let's start from the beginning. The story involves a lot of details, so let's break it up into parts. Let's focus on these two sentences. Notice that Alice takes a counter and then puts it back in the bag, and Bob does the same thing. These details indicate we are sampling with replacement. The probability of drawing each of the colors is the same on each draw. Consequently, let's focus on the first sentence that the bag only has red, gold, and green counters. Since we're sampling with replacement, we can specify a probability for drawing each color. Let's write x to be the probability of drawing a red counter, y to be the probability of drawing a gold counter, and z to be the probability of drawing a green counter. Now funnily, you actually don't need this variable z because green counters don't play a part in the equations and in the ultimate solution. It's a little bit of a distraction. Now let's focus on the next sentence. The probability that both counters are red or that both counters are gold is 5/16. What's the probability that both counters are red? We need a red counter on the first turn, and then we need a red counter on the second turn. Notice it's the same probability because we're sampling with replacement. This becomes x times x, which is x squared. We can do a similar calculation for the probability that both counters are gold. We need a gold counter on the first draw and then the second draw. This will be y times y, which is y squared. Now we want the sum of these two events to be 5/16. This is going to be x squared plus y squared is equal to 5/16. Let's then focus on the next sentence. What's the probability that the first counter is red? Well, that'll be x. We then need the probability that the second counter is not red. So we want to multiply these two probabilities. Since the probability of drawing a red counter is x, the probability of drawing a not red counter will be 1 minus x. We multiply these two together, and we have x times the quantity 1 minus x. Now we need this to be 1. We have a single equation and just one variable. So let's expand this out and solve this quadratic equation. Get the solution of x equals 1. Make this solution and go back to our other equation. When you break it down into steps.
I love the way she makes me smile, she makes me smirk.
Yes, sir.
It gives me chills, it makes me blush, it gives me worth.
Work.
And I can see her winning the Miss Universe. And if heaven does exist, it will most probably look like